Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today, in this video, we are going to see about the polymers and the composite materials. So, these polymers and the composite materials are shaping our world. So, materials they revolutionize the daily life, and also there is a change in the technology. If you see the polymers, it's globally it exceeded some $620 billion in 2023, and these composites they surpassed $110 billion in 2023. So they are used right from the packaging materials to aircraft. So how do you understand the polymers? The polymers, they are built by the monomer units. The monomer are the small units which build up to give the polymer units. Okay, so the polymers are long chain of repeating molecules of the monomers, and these polymers they are light, versatile, and cost-effective materials. And the diverse sources they synthesize from the petroleum and also from the natural gas, or they are biosources. They have biosources. So there are different types of polymers that are synthesized by various methods. And the common examples of the polymers are polyethylene terephthalate, polyvinyl chloride, HDPE. These are the common type of polymers. That is the polyethylene terephthalate. They are used in the clear plastic bottles and food containers. Then PVC, that is the polyvinyl chloride. They are very commonly used in the water pipes, window frames, and vinyl flooring. So HDPE is the high density polyethylene which is used in the jugs, detergent bottles and many other materials like playground equipment, etc. Then one more thing is the polypropylene which is called as PP. It's used in the bumpers, yogurt containers and the bottle caps. So how do you know? What do you know? How will you introduce the composites? That is, composites is not. It's not just a simple material. Like composite, it is not made up of a single material like that of the polymer. It is a combined materials. That is, two or more distinct materials are combined to form a composite material. So this it is done to enhance the properties. The different properties of the material is enhanced. That is the properties to outperform the individual composition. So reinforcement and the matrix. So these are the main components of a composite material. So you have a certain material for the reinforcement of the materials. That is like they are usually done by fibers. Fibers will be made up of a nanomaterial size, and you have a matrix. It's a phase. It's a long continuous phase that is called the matrix that may be made by the polymer, metal, or the ceramic. It will be a long continuous phase, and the reinforcement materials like fiber it will be added to the phase. It is discrete, and the matrix will be a continuous phase. So these composites, they are engineered for the performance. They're engineered for specific high performance applications. So composites are all around us and they give an enhanced performance. So they are used in the sporting goods, automotive, aerospace, and also the infrastructure. So in the sporting goods, the carbon fiber, tennis rackets, and the bicycle frames, they are used by they are made used by the composite materials, and the automotive is lightweight body panels and the interior components. When an alloy or a metal is used for the automotive part, it will be heavy. But when it is made up of composite material, it will be more flexible and it will be have a lightweight. So aerospace, so aircraft fuselages and wing components. So they should be a little lighter in weight and also they should have a good quality. So these are made by the composite materials, right? Then the infrastructure, so bridge decks and the wind turbine blades. So these are also made by the composite materials due to the enhanced properties and the lightweight. So special organic polymers, that is the polyacetylene. Okay, so now we are going to see about the organic polymers, that is the polyacetylene. It was first discovered in 1958. So you have a different conductivity that is made conductive by doping, and the discoverer he won the Nobel Prize in Chemistry 2000 for the conductive polymers. So this polyacetylene polymer, it has a special property, that is the conductivity property when it is doped by certain materials. So these are used in the applications, are used in the OLEDs, sensors and solar cells. So polylactide, this is also a special organic polymer and it is represented by PLA in short form. So they are bio-based polymers. PLA is a bio-based, biodegradable thermoplastic polymer. So they are derived from the renewable sources, resources like cornstarch and sugarcane. So the speciality of this polymer, it is biodegradable, and the biodegradability, it decomposes in the industrial composting facilities within 60 to 90 days. So they do not contribute to the pollution in the environment and they help the environment sustainability. So applications include 3D printing filaments and medical implements. So fiber reinforced plastics or FRPs. Okay, so these are having a very good strength. Fiber reinforced plastics have a very good strength. That is, they are used in the polymer matrix used over here is reinforced with high strength fibers. So some exceptional properties in this FRPs are offers exceptional strength to weight ratio and corrosion resistance. Load bearing, fibers bear the load, while the polymers matrix protects the binds. Key types. So the key types include the fiberglass, carbon fiber, and aramid fiber. So these are the different types of FRPs which are in most important uses. So FRP, when it is used in action, that is, they have a high performance solutions. So FRP is 5 times stronger and 2 by 3 times lighter than the steel in specific applications. So they are preferred over the steel. So aramid fiber, they are called the Kevlar. The ballistic vests, ropes, aerospace components, here we use this type of fibers. Fiberglass, GFRP. The boats, okay, 90 percentage large wind turbine blades. All these things are made up of the GFRP fiber. Then the carbon fiber, CFRP. That is Boeing 787, the plane. Okay, formula in the first chassis, high-end sports equipments. All these things are made up of the carbon fiber, which is in short called as the CFRP. The future of materials. So the future of materials, of these materials, there is so much innovation and sustainability in that. The advanced materials. Why do we go for the advanced materials? Continued development of advanced smart materials is ongoing. It is focused on the sustainability. So there is an emphasis on recyclability and bio-based alternatives of these materials. Performance drivers. Driving, lightweight and performance is the key in the industries. So it is important to have a good performance with a lightweight. And next is the technology process. So it's essential for sustainable engineering and technological process. So as the technology advances, it's important to care about the environment and the sustainability and also the high performance with the lightweight. And also it should be cost effective. So we are going towards the innovation and sustainability. Thank you.